All right. So, hello, everybody, and welcome to our webinar, AI and Simulation, What Executives Need to Know. This is a joint event organized by the AnyLogic company and our longtime partner, the engineering group. So we have two speakers today. This is myself, and I'm Andrei Borshchev, CEO and co-founder of the AnyLogic company. And we have Luigi Manca. We've known Luigi, it's been more than a decade, right? Probably 15 years. So engineering group and AnyLogic are partners, have been partners for a long time. And maybe Luigi, you can tell something about yourself and your what do you do at the engineering group?
Yes, of course. So then, thank you, Andrei. So let me just briefly introduce myself. I'm working in the simulation space since 2009. When I met then AnyLogic in 2011, I was working for my own company that had been acquired by engineering. And inside engineering, that is a digital transformation company or a system integrator. I'm acting as the director for everything that stay in the simulation, decision intelligence. So all the applications that are helping our customer in getting better decisions. And then I will explain you a bit later after the end of the presentation.
Very good. So let's start. And we will start with this slide. Now, what is this where we're looking at? So I think this is a kind of typical management bullshit slide. So let's say you have a presentation to the leadership in half an hour, and you ask your favorite LLM, oh, please, I'm not ready with my deck, so I need something with the keywords like technology, vision, strategic thinking, forward thinking, whatever. And this, there is a probability that like ChatGPT or other LLM would generate to something like that. Now, our goal today is to guide you guys a little bit through this mess. Not through all of it, but through the parts of that we know and we work with. So let's try to make some sense of this slide. First of all, it's not entirely bullshit, because what we see on the screen, we can call like a technology stack of digital transformation. So let's draw some lines here. First of all, we have data, of course, real data coming from devices, coming from softwares we use. And we can feed that data into simulation, and simulation will then generate synthetic data. Now, that synthetic data can go to BI, it can go to NVIDIA Omniverse, and then VR is enabled. We can create a predictive digital twin with the help of simulation. And by the way, we can also do a simpler version of digital twin that will just mimic what is happening in the real world. We can, of course, leverage different kinds of AI, and we'll be talking about that today. And we can also do, let's say, old school AI like ML, because we can use simulation to train and to test artificial brains, and they can consume real data and synthetic data, all that sort of stuff. So today we will be focusing on two technologies. First one is AI, and the second one is simulation. And we will try to talk about, okay, are they alternative technologies? Do they compete? Can one replace the other? Can they work together? And if they can, how? And with that, Luigi, please go ahead.
Yes, thank you, Andrei. So to me, the topic today is really what you said. So we will succeed if we will be able to give you some news about what is the biggest hype that we are living today. No, it's not the toothbrush, because again, by the way, this is a very good toothbrush. I have the same brand, so very good. But do we really need AI in everything today? So probably marketing has gone too far. No, And so our job today and my goal today, so Andrei, we will succeed if we will be able to give the audience and to you guys the idea that probably where you should apply AI. And most importantly, where not, where other tools can do the same job, no? And again, this is where we want to go. But let's be honest, Andrei, so this is not a trend, though. So this is not just an hype. This is something real. So we know that McKinsey just said it's 4.4 trillion global economy annual value under AI. Yesterday, NVIDIA overpassed 4 trillion evaluation. So this is a big thing. So this is true. This is real. And again, the trend of the AI, in my opinion, is really important because we especially, I'm from Italy, guys. So especially in Italy, here we are living one trend that is called the demographic winter. So people are we are not get any newborn anymore, and so people are getting older. And if you want to stay competitive in the market as a country, so we will need to have some help from technology, from AI, from robots, from whatever, to get this shortage of skilled technical talent. And again, probably this is where, I guess, in an optimistic way, we will get some people that we will be more focused on doing high value tasks or skilled on high value topics instead of doing the boring jobs. I don't know, what do you think, Andrei, on that?
Well, first of all, well, of course, all consulting companies are trying now to very much sell and advertise AI because they're about, you know, transforming somebody else's businesses. Well, I can accept that. I wouldn't be that optimistic on the kind of the last paragraph of your slide. So to my mind, there's a more probability that, you know, humans will not focus on high-level, high-value work, but they will focus on staying home, ordering food, playing video games, and probably only the most intelligent of them will watch Netflix sometimes. Otherwise, I'm with you.
Yeah, okay. It could happen, but let's stay optimistic. So otherwise, I don't know, but probably Terminator will come. So
All right.
will become a reality. But let's just focus a little bit on that. So let's say what is actually the AI today is already good in doing that. So to me, AI is already on great production tools that we have, and we can focus on some different kind of AI. So what is called apply AI or narrow AI. So it's the AI that is specific to do some practical tasks. So we can deny, Andrei, that on computer vision, AI is very good. So if you need to get defects on some biscuits or whatever is going up to your line really fast, AI is perfect. Predictive maintenance, self-driving vehicles. So we have all seen how Tesla or other companies are doing on this field. We have generative AI. So I don't have to tell you about ChatGPT or whatever, how it's good to create you some content. Then we have the new stuff about agentic. These are really still in the research side, but on personal assistance, on some kind of workflow automation that is much more than the RPA, so robotic process automation that we had so far, is really going through. And again, on the optimization side, so we did something in the past. We also, with simulation, we did some tools that we will talk later. But to me, these are really good applications. But the fil rouge, so the common things behind all these topics is that today AI is really good in helping us in reducing human error because on boring or repetitive tasks, and when the things are getting frequent, so this is where AI is excelling. So it's a very good companion at the moment, and to me, it's a good thing. It's not replacing us. No. Just to give you some examples, so I don't want to go through these. These are examples that you can find on internet. We gave you the sources where we can find when we will send you the presentation, and these are some topics that are reflecting what I said before. So for example, on precise agriculture, so where you see and spray the weed, so by reducing pollution and by reducing the consumption of very bad stuff. So this is good. Or on IT services, when you have multiple tickets to reply and the reply could be repetitive, again, this is a good news. Or automatic optical inspection or algorithm trading. So when you have really fast task to do, this is where AI is really going to get the clue. But Andrei, we cannot ignore something. That is something that we don't govern, we don't fully understand. It's still a black box. So no, this is to me is really interesting because this is a research that I found on Anthropic, and Anthropic are the guys behind Claude. That is one of the best foundation model that we have so far. And these guys in Claude, in Anthropic, are really focusing in understanding and in the research about how AI really works and how is the explainability behind the AI. So one test that they did, and this is a simple example that I want to give you, is about they asked Claude to explain how to make the sum of two numbers, 36 and 59. And the Claude explanation was simple. So it replied to the user, I just add 9 and 6 and 9, so the units, then I carry the 1, and then I make the sum. So like everybody is learning in an elementary school to make a sum. What they did instead, and what they discovered, is that behind the scene, by following the chain of thoughts of Claude, I can say the reality is really different. So I don't know if you can read, but you will see that, again, there are so many thoughts behind and about approximation of numbers, something that is really different behind the scene. That is not what is telling us. So the real answer, so it goes to the right solution, but using a very different way and very unique way. So something that we don't really understand. So my question is, how can we trust something that we don't fully understand? And if we are going to getting accountability or responsibilities in terms of lives or in terms of, I don't know, a big investment, how can we trust to this new technology? So and more often we know that this kind of foundation model has been trained over the, like I said, the entire knowledge that is available on the internet. Okay, but if they need to decide on something that is not so, I can say, so common, something that is unique, something that is a niche, or something that is new in your company, Andrei. So you have a new product, AnyLogic 10. How do you think that it can help you? I don't know. Again, I let you reply on that.
All right. Luigi, thanks for this example. I did it. Okay, so I did a similar thing with ChatGPT, and my experience is, I'd say, better. So here on the right-hand side, this is a human like myself, and on the left-hand side, there is ChatGPT, right? So my question was, what is the product of these two fairly large numbers? And within less than a second, ChatGPT came back with this answer, and that is the correct answer. Now, okay, my question was, how did you do it? Because clearly, the probability that ChatGPT or any other LLM would have been trained on exactly these two numbers is 0, right? So the answer was that, well, I used an internal tool, specifically a Python. So I wrote a Python program, executed it, and here's the answer. So the thing number one to be noted is that an LLM is not a pure LLM. It has some, I would say, non-AI engines in the backyard, right? So ChatGPT works with these engines seamlessly to you. You don't see that. And its answers may be based not only on its kind of knowledge, right, on what's on its prior experience, but also it relies on other technologies. So, and this is number one thing to be noted again. Now, let's take it a little bit further, and I will start gradually introducing simulation here. So, okay, if AI can replace a calculator, can it possibly replace a simulation tool? So, my question is, okay, what would you need to fully replace a simulation tool? And this is the answer. So first of all, I need to have a simulation tool in my, let's say, toolkit in the backyard. This is number one. Number two and number three is basically, okay, I need the tool, I need this subject matter expert and the modeler. So this is a little bit too much, and that basically says that in the nearest future, we need to have at least human in the loop, right? To build simulation models with the help of AI. However, there's a second half of the answer. And the important thing for us here that even ChatGPT itself says that if we ever will be able to integrate AI and advanced simulation engines, that will be certainly a game changer for simulation workflows. So takeaway from the number two from this slide is that integration of AI in simulation is very, very promising. And I think next slide is yours, Luigi, right?
Yeah, and again, I'm very glad that again ChatGPT said that we need the domain expertise into the loop, because what I want to discuss now is that following the previous discussion that we just had is about that when we go to strategic decision and when you have strategic choices, so this involves something that is deep domain knowledge, understanding, or empathy, or something that is really where human is really going to get the clue. And this kind of stuff cannot be just based on belief. So we cannot just base on something that we don't really know how it works. Because again, as you just said, so AI provides really well answer. But if we need to get the human in the loop, as you just said, so this is where the decision maker, and luckily we are still the decision makers. We need to play, we need to explore, we need to stress test our assumption, because the future is uncertain by definition. And you are teaching me, Andrei, so everything is complex. So you cannot trust something because it's a number. Okay, so to me, this is where, and sometimes it's always also a matter of visualizing the problem, no? So understanding and breaking the mental boundaries. So by give the visualization of how things happens during the time, this is good. And this is where simulation excels. So this is where, to me, simulation cannot be replaced, because every time so we need to make decision on complex systems, we need to models to us, even though these models are not perfect. So this is where we need to get some information about works, and we need to judge with our human intelligence on how we can use these quantitative numbers by combining with some qualitative information that we have in order to get the right decision. Because we know the context, we know the people we are talking with, we understand the tone of voice, we understand. So right now, all this casual understanding and not just correlation or prediction or pattern recognition cannot be done without simulation. And Andrei, I let you better explain than me what this simulation is like again. So.
All right, thanks, Luigi. Yes. So guys, do you know that in culinary contests, it's not allowed to use things like truffles or something else? So I think it's probably not good to use cats, but I did it anyway. To explain it, basically to illustrate what Luigi just said. We have AI, and AI is a very smart black box, right? Now, AI accepts all kinds of inputs. We know that. So these dots could be video, it could be images, it could be CAD drawings, data sets, audio, text, whatever. And what does AI do with that? Let's see. All right. So AI can say, first, there's a cat. Second, based on its pose, it might attack. So watch out, right? So AI, and this is important point, is really great at connecting dots, at recognizing patterns by looking different, all kinds of data. And this is probably even more important. The predictions that AI makes is based on similar known patterns, known examples known to AI, its reference cases. Now, how about simulation? So first of all, simulation is not a black box, it's a white box. You know everything what happens inside a simulation. You know exactly how the simulation engine works. Doesn't matter whether this AnyLogic or I know MATLAB simulation, we know how it works, we know what's inside. Now, thing number two is that simulation is a lot more demanding on the input. You cannot just supply arbitrary kind of data to simulation. No, you cannot do that. So you should build a model. So, okay, this is a cat, or this is a warehouse, or this is a factory floor. This is where things are. These are the objects properties, like the cat's mechanics, dynamics, behavior rules, etc. So you have to work a lot more on the input to the simulation, but in return, simulation will generate you a scenario of a possible scenario of how things will unfold in time, and that scenario could be very different to what have been observed before, and this is one of the biggest value of simulation. So kind of takeaway here is that okay, simulation accepts the system state and behavior as input and generate possible a variety of future scenarios, including those that never happened before. And this is not the only one. Number two is simulations and fully transparent. It shows you why things happen. You can trace everything, you can measure everything, and therefore simulation can provide more trust and more insight, probably. And my main point here that AI and simulation solve, I'd say, different classes of problems. And one more thing we will do here, just one more slide. It's kind of highlighting one of the other advantages of simulation. Simulation is really great at handling uncertainty. Now, what is uncertainty? Oh, well, there are things like non-determinism, deterministic, probability distributions, uncertainty, all that sort of stuff. Now, there's philosophical aspect of that. We can argue whether our universe is deterministic or not. But in our field, we call uncertainty things that we don't have full knowledge about. Like we know that to a grocery store, there are that many clients, visitors come in the this morning hour, but we don't know exactly when they come or why they come, right? So, all right. So what you could do, you could take your historical data, and that historical data would correspond to one scenario. And this curve may represent anything, I don't know, resource utilization, response time, any other metrics that are important for your business, right? You can add more data sets, it'll add one more curve, third data set, and it'll add third curve. Now, okay, can we rely completely on what we have seen before, on what has happened before? No, we cannot. Because, of course, historical data is important, but it doesn't cover everything. And if you only focus, and if your decisions are only based on things that have occurred before, you may miss very important situations that are still possible. Now, simulation takes different approach. So simulation model, instead of using historical data, which you still can do that, but it's a lot more useful to use a probability distribution that is fitted with historical data. And then simulation will generate as many scenarios as you wish, covering a lot wider set of scenarios, set of situations, right? And therefore, like these 60% of scenarios up there, like green and blue, may be okay and good, but these are not, and they might be missing if you only rely on your real data. So I guess most of you guys who are listening to us right now are simulation professionals, so you know that as well. But as long as we're giving overview of the two technologies, it's very important to have this in mind. And I think Luigi, you go next, right?
Yes, exactly. So thank you, Andrei, for the explanation, because again, this is exactly what our customer is asking us. So let me put in the shoes of the director of the simulation practice in engineering, and I can see that this is where simulation is really bridging the gap, helping us in bridging the gap between conceptualization and execution. And many times, so the most of the times, our customer is asking us to let me envision the promise. So let me envision something that is I don't know. I want to optimize my capital investment. I want to make efficiency in my production. So maybe you as a consultant is helping them in designing all this stuff, but with the simulation, you are capable of helping them in understanding how reliable these scenarios are, because they can test, because they can play with uncertainty, because probably the demand that I foresee or the new plant that they are building is based on some assumption of the demand. But what happens if the demand will not happen in the future? Sorry for the joke of word. Then let's understand how the simulation will evolve. And so let's try the best trade-off sometimes, or the best scenarios on which you can have the return, the best return on investment, or the best the lower risk in all these decisions. And so, as you said, Andrei, just to stress what you just said, and that simulation is helping with a transparent box to give this answer, and is also giving the power to non-technical stakeholder to play with something that could be really technical. So if you build a very good simulation tool, then you will be capable of demonstrating and getting into the problem. Some people that maybe 99% of their time are flying at 10,000 feet of your specific technical problem. And this is the very plus of simulation. I can go, if you probably we are in time, so I can go briefly to some of the examples that we did in the past that to me are representative of these things. And please, Andrei, stop me if I'm going too deep. So I trust you on that. So 3 examples. So the first one is about supply chain. So we know how supply chain are complex. We are experiencing all different disruption in supply chain during this year. So the Suez channel that is stopping because of the ship that is stuck in the middle, or the lack of water in the Panama Channel, or whatever. So again, so one of the problems that we are helping our customer was about designing the supply chain, the best supply chain for a new kind of drug, for a new kind of vaccine. And we design a simulation tool on which they can play, and the different stakeholders, so supply chain, production, purchasing, and other different functions into the company were capable of working together on a same model, so be on the same page, and to play around together in the same room about how one one action from their side could impact during the time, or during the months or the years, some other department that they were not aware about because of the complexity of all the supply chain. And so this kind of tool was really helping them better understanding each other. So really getting them to converge much more faster to a common solution that would get the best performances for the company itself. This is a fact. So another example is about smart manufacturing. So we work with one of the top semiconductor manufacturing companies by helping them into the process of designing the new kind of factory. So what do they call the factory of the future? So how to create something that is driven essentially without human into the factory, so can work 24 hours in a very narrow space, because in the semiconductor industry, every centimeter, every inch matters. So if you are capable of shrink the space, so you're saving a lot of money. But this need to work. And again, with AnyLogic, because the tool behind was AnyLogic, we were capable of creating different scenarios really quickly, in which they with the strategic consultant that they also were into the project, were capable of playing scenarios, understanding better the scenario, and then getting the best decision that was optimizing the ROI. Or in a similar way, in another company, this is an online retailer, very huge, so everybody knows this name, where it was in the process of changing a certain kind of equipment, but it couldn't stop the operation in the plant. So it was asking us a tool about understanding the best strategy to decommission and to retrofit this new machine without disturbing or reducing at maximum the disruption that they could have on the other lines that were working. And we made this model for them. Then they asked for a model that could be reusable also for new in the future for other machine that they could happen in some times later. But again, this is, to me, these examples are showcase how simulation is really helping companies. But there is something more, probably, Andrei. So we need to talk about some integration. So I let you.
All right. Okay. Yes. So as Luigi said, we're approaching an important topic and how simulation and AI can work together. And let's consider this case. I would not call that a failure. I would call that a false start. So the story is that, believe it or not, there were times there were no LLMs around. When we thought of like AI, it would have been not LLM, but things like trained neural networks, machine learning, reinforcement learning, etc. So the idea was, okay, if we can get AI efficiently play chess or play Go better than humans, why can't we get AI control our manufacturing, supply chains, road traffic, etc., etc. And if so, the idea was that if we do it, then simulation would be the only option to train these artificial brains, because it's how else would you train AI to control a warehouse, right? Of course, you would not let it control a real warehouse. It would let it into a simulated environment. So you build a model of a warehouse and train neural network. So, and these are the three possible integrations of AI and simulation as of, let's say, 7 years ago, or maybe even 5 years ago. So, of course, simulation can generate as much synthetic data as we want. It will be labeled and perfect input for an AI to learn. The more interesting architecture is in the middle, where we have a neural network being trained in the loop of a kind of living simulation at runtime. So it makes an action, the model changes, sends its state and the reward, and that works in the loop. And of course, you can have a brain trained elsewhere. You can incorporate it into a simulated environment. Again, let's say, for example, this brain is to control inventory policy in a supply chain. This is a model of a supply chain. Now, this all is valid. This all stays true. However, projects like that are not happening massively, not at all. And the reason they are not happening massively is the complexity. So each project like that requires just too much human brains to set up. And so it never became a commodity. However, advanced companies and engineering being the one, did successfully performed a number of projects of that kind. So I would ask Luigi to talk about those projects.
Yeah, thank you, Andrei. And again, I agree with you. So these are 3 examples of projects that we did during this year. And again, we presented one of them, the central one, at the AnyLogic conference in 2019. And at the time, where was still the hype for machine learning. So we were still talking about machine learning. There was not AI. So we were talking about deep reinforcement learning. But you are right. So we succeed on these projects. And again, we create some tools that can better control the climate in the HVAC system inside a room or inside like I say, data center. And we were capable of cutting some energy cost, or we were capable of moving this product around. Let me see if I can. There's a pointer. This product around on the production environment in a really good manner. And this project is a nightmare. I don't tell you how many millions or billions of possibilities you have in these simple lines, where you have 12 different products that are running on this line. at the same time. But here the topic is about that we succeeded because we were capable of succeeding on this project, and these are working really fine. But the effort behind is not negligible. So we spend a lot of effort, and our expert, the expert in my team, were really struggling their head in order to fine tune the models or fine tune the simulation in order to make it running properly. So this is working, but this is not an off-the-shelf solution. Now, so
yeah, so yeah, you're still continuing through the slide, right? Or because
yeah, no, again, to me, we can skip it. These are just samples.
Yeah. Just to remind you guys that what do you see? I mean, these projects were done before the LLM, and they have nothing to do with LLMs, right? They have something to do with specific AI neural networks trained just to solve one particular problem, right?
Yep.
And the way they were trained and tested is by putting them in a simulation model, in a simulated environment, right? And the complexity goes from both sides, right? First of all, AI itself is complex, right? And then simulation is complex, and building the right simulation modeling, setting up the learning process is really, really challenging. Would that be correct to put it this way, Luigi?
Yeah, you're right. So it works because it gives you a very powerful application, so a powerful agent, we call agent today, that you can deploy in your production, but it's not for free. So it makes you still a lot of effort. And today we need to talk quietly because it's the 10th of July. I don't know what will happen tomorrow because these things are running so fast that things can change.
Yes, and what I would expect, there'll be a second wave of this because technology is progressing, simulation is progressing, and AI is progressing, of course, very rapidly. So I would anticipate another wave of interest, and let's say ML plus simulation 2.0, whatever, revisited, maybe in the very, very near future. But let's move forward. I wanted to say that simulation is also progressing, and just to confirm that, this slide. So simulation today is different to what it was 5-10 years ago. And this is why and how. So in any simulation project, you have stakeholders, of course, and you have simulation modeling experts who may or may not be subject matter experts, or they work with subject matter experts, and they build models, right? So they do all these conceptual modeling, spatial modeling, coding, debugging, validation, animation design, etc. So let's say 10 years ago, what these guys would deliver to the stakeholders is a report, I know, Excel file, a PDF, maybe the video, maybe a demo, and then after that, a simulation model would have been thrown away. These days, things are different, and this is good because, to my mind, simulation model they deserve much better and longer life. So what is happening? We're evidencing massive operational use of simulation models. So, and simulation is shifting from project-based to operational. And this, of course, we are very, very happy about it. However, operational use, of course, imposes new requirements to simulation. So now you should have, a online repository for simulation models, a very efficient execution environment with 100%, well, not 100%, okay, 99.999% uptime. You should have very good data connectivity and API, so you can integrate it into the workflow. right? Web front end, of course, user management, et cetera, et cetera. And of course, we at AnyLogic have been working on this since probably 10 years ago. So with AnyLogic and AnyLogic Cloud, we're providing all these things that are here on the right. And then, but also we see more opportunities of AI, another kind of AI integration. So first of all, what is already happening, AI is used to help modelers to do coding in simulation tools. This is a commodity these days. It also can help well with debugging, because if you get something wrong, you can recognize why and then tell you what should be changed, corrected, right? On the execution side, AI is great at interpreting these. By the way, I'm sorry, but these three circles should be at the bottom. So it should not be version update management, of course, but it should be here, output analysis and interpretation. So there, it's well known, but I'll repeat it once again. The AI is great at connecting dots, and these dots could be data sets, synthetic data generated by simulation. So analysis of simulation outputs is one of the fields where AI is really, really helpful. And also, and this is another thing we're working on at AnyLogic is, and not only us, by the way, there are a lot of projects like in system dynamics, AI helping building models, putting together models, helping with conceptual modeling. So we will be probably showing something of that type in the upcoming AnyLogic conference. But the takeaway from here is first thing, simulation is more and more used operationally these days. Second thing, this of course imposes new requirements to simulation, and in this case, AI will be helping us to both develop and use simulation models. Okay, and then Luigi?
Yeah, I'm really curious to wait for the AnyLogic conference to see what AnyLogic will like integrated with AI. So so we are at the takeaway. So we are running out of time. So to me, the main topic is technology is not the solution. It is the toolbox. So we need to master our toolbox. And the main takeaways that we like to give you is that, first of all, you need to know what each tool does best. And to me, one red line that is still valid today is that AI is really good as an executor for fast, repeatable, data-rich tasks. These tools are already in production and they work perfectly. But simulation is very good, is the best tool in which you need to challenge and plan your decision or your changes, even under uncertainty. And Andrei explained much better than me why this matter. And we need to understand when to use what tool, because sometimes you don't need to have something that gives you an answer, but you need just something for exploring solution. And again, or you don't need to add to have an approximation when you have an exact answer. So you won't use ChatGPT to give you the, I don't know, the formula about universal gravity, because we have the formula. Newton's made 200 years ago, and it's still valid. So when you have some tools that, when you have the exact answer, probably it's better to use something that is less computational intensive. Okay, so simulation, a calculator, whatever. Sometimes instead you are need for something that you don't perfectly know, or that you need to approximate so fast, and then probably some AI can come to the rescue. Okay, And again, going to what is just said, Andrei, about the operational use and the trend about operational use of simulation. And this is, to me, where we can see the best of integration, because, again, this is despite the first point in which, to me, there is still a quite very good separation, the third one is a gray area, is a battlefield on which we don't need to fight or to choose between simulation or I can say, or artificial intelligence. We are not competing. We need to integrate them, because you just explained that together that they can work really well, and there are really a lot of room for improvement. Because again, we demonstrate that simulation plus AI is working with the project that we did. But again, for sure, it can be done probably in the future simpler than that. And again, you can do some very good decision without sacrificing the clarity, as we said. So you don't need to go with a black box when you can go with a transparent box, helped or supported by something that is speeding up your decisions. And to me, these are the main takeaways. I don't know, Andrei, if you have something to add on these ones.
Yes, I have something to add here. First of all, and you did it already, I would not reduce simulation to just a test bed, because you talked about operational use of simulation. Actually, predictive digital twins are all based on simulating forward. Okay, you take a snapshot of your system, you simulate forward, you provide the answer, and maybe you make a decision. Now the system operates, and at the next point in time you do it. So and that's one of the examples of operational use of simulation that we're observing more and more. Now the other takeaway I would like to once again talk through is that AI and simulation are not competing technologies, not at all. They solve different problems. They generate different kinds of outputs, and they are good for different things. So, and I see there is an answer, because I already looking at the Q&A things, Q&A panel here. So one of the questions was, why are we comparing AI and simulation directly, as they are solving different problems? So, and this is a question from Lily Hell. So Lily, it's great you understand that. We understand that too. But as long as this is the webinar mainly targeted for management, not everybody understands that, because many would think, okay, AI will replace everything, every other technology. And our point, it is not true. And then again, once again, where AI and simulation are different is that AI only can rely on its prior experience. It is not capable of generating completely new valid scenarios. And simulation is vice versa. Yep. Okay, so I think we have just one more slide from you, Luigi.
Yeah, so this is about understanding who is, just to give you 1 minute or even less about what is Indus' Excellence, so the company I'm working with. So we are, as I said before, a system integration company, and Index or Indus' Excellence. So you can find that index.com. You can see our website is about giving services around all the services around manufacturing or supply chain. And we are working from the design, so we are following what is called digital thread. So from the design automation, so PLM, going to the factory, so by installing manufacturing execution systems, or having the tracking and trace of the product, through everything connected with what we did and what my team is doing globally about trying to leverage all this information or all this possible problem and transforming them into kind of tool that can help you in get a better decision. So this is eXcellence in a nutshell. And again, I think that we can spend more time on answering
Q&A. Yeah, if you could display the next slide. Just very quickly, we have conference on September 9. You're very welcome to attend and or to speak at the conference, and all the links are there. It'll be online, and so please, guys, save the date and think of presenting. If you have a if you have a good case study, you're more than welcome to speak at the AnyLogic conference. And okay, Q&A, very quickly, we can take a few of them. So first one is AI already widely uses prescriptive maintenance with use cases. Luigi, I think this is your question.
Yeah, I think this is not more than a question. This is true. So this is a fact. And again, but this prescriptive maintenance is really going into what you said before, Andrei. So this is about pattern recognition. And this is where prescriptive maintenance predictive or prescriptive maintenance is working on, because it allows us to understand when an equipment is failing, and on the prescriptive side is also getting the Gen AI on top can help us in getting some answer on how to reading the documentation of the machine on how to do that. So it's a fact. So I agree.
All right. Thanks, Luigi. I think question number 2. Are we really comfortable with automating more and more? Behavioral science as well as experience suggests that management would prefer to cut staff. Well, I'd say that to me, it's useless to fight progress. AI clearly is progress, and we have to live through it. And I'm very optimistic. I'm about the mankind. I think we can handle it, and I don't think I am very much against people who try to kind of stop progressing AI. No, it's not going to work. No, it's not going to work. So I'm very much for progress, and again, I'm very optimistic about it. Now, question number 3: where does agentic AI come into play in simulation? So, Luigi, I guess would I be correct to say that the scenario where AI agent is being trained in a simulation environment is one of the examples? Is this correct?
Absolutely. This is the best way to describe it, because when we call the deep reinforcement learning now is an agent, and then you can train multiple agents to do stuff by leveraging synthetic data from simulation. And also NVIDIA is working on that for robotics. So they're leveraging simulation, other type of simulation than AnyLogic, but to train robots in the real world.
Mm-hmm. All right. So how is AnyLogic incorporating generative AI? Okay, visit AnyLogic conference on September 9, and you'll find out more.
Don't miss the event.
Now, okay.
Can I use AnyLogic personal learning? No.
Okay, is there LLM into AnyLogic ID? Is the same kind of question, but Luigi, can you talk about the time that was required to develop these AI and plus simulation projects?
It's really dependent on the problem. So despite the first one was really intense, because we need to understand how these things were working together without any integration, I think that an average is taking, we are not talking about weeks, we are talking about months. So it's from 3 to 6 months to create something like that.
All right. To what extent does AnyLogic view the proliferation of free open source simulation frameworks such as SimPy as a challenge to complement the conventional? No, I don't. If you there are good resources on SimPy, especially like one person, I don't remember his name, but he has a blog, and he's at a SimPy school. So, and he has a kind of battle cards: SimPy against FlexSim, SimPy against AnyLogic. And basically, if you read these battle cards, the only reason to use SymPy is that you don't have money to to buy a commercial off-the-shelf software. So basically, you can't compare with regards to simulation software. No open source packages is nowhere near commercial packages, and in our space, I don't believe in open source, free open source. Consider, for example, the failed project of Hash AI, et cetera, et cetera. So basically, if you want a professional tool, you buy something, and if you don't have money, you can use, well, by the way, you can use the AnyLogic PLE. It'll still be better than SymPy. Okay. I don't know. It's already been an hour, so I don't know whether we should continue that or we should finish. So Ryan, if you're hearing me, please let us know.
So I think that in any case, because some of the question has been answered by Jeff or Roman,
Yeah.
so I think that we are fine. So
can I use let's do just one more. Can I use AnyLogic personal learning for my project using integration of GIS and AI agent using RL? Yes, I mean from what I see, all the technologies you listed in your questions are available in AnyLogic PLE, including RL. So yes, you can do it. Okay, guys. Thanks very much for attending. Luigi, thank you. It was a pleasure to share this webinar with you, and yeah, so very much looking forward to our future technology progress, both in simulation and AI. Looking forward to our continued collaboration with engineering team. And guys, see you all at the AnyLogic conference in September. Thank you very much.
Thank you so much. Thank you, Andrei.
Yeah.
Thank you, everybody.
Have a great day, everyone.